In the future, we might try to build a spaceship with advanced propulsion capable of light speed. But the laws of physics won't make it easy.
There's a barrier to how fast you can go, a speed limit. Then that is the speed of light. And this is just a fact. This is known observationally to be true. This was in fact measured in the early 1900s, and it is the reason that Einstein came up with the theory of relativity.
The central tenet of special relativity is the speed of light. Nothing can possibly go faster than the speed of light, and no observer can actually watch light in a vacuum going any other speed. It's always exactly the speed of light.
The speed of light is a fundamental property of our universe.
In a real way, the speed of light is not as simple as just a velocity. It's an intrinsic way the universe is put together. As you move closer and closer to the speed of light, time for you compared to another observer begins to slow down more and more, until incredibly at the speed of light, time doesn't progress at all. And this is one of the most mysterious things about the universe to me. Light is so common, it's all around me right now, but light does not experience time.
If you keep traveling faster and faster and you exceed the speed of light, Einstein's theory of special relativity tells us that your clock slows to a stop, but then begins to tick backwards.
But no matter how advanced your propulsion system is, the universe will never let you travel as fast as the speed of light.
It would take an infinite amount of energy to accelerate something, a car, a marble, a galaxy, whatever, to the speed of light. And so for that reason, we think that the speed of light is itself a truly unbreakable speed.
If you want to take a human-sized spacecraft and accelerate it to 10% of the speed of light, let alone 90% or 99% of the speed of light, it requires more energy than humanity has ever used in its entire existence and probably will ever use in its entire existence.
Jumping forward in time isn't simple, but the physics of the universe make it possible.
Going close to the speed of light slingshots you into the future faster, but it does not take you to the past in any way. It's not a way to go backwards in time and visit anyone's party.
A super-fast time-traveling spaceship can't take us back to Hawking's party. But what about a time machine that exists out in the cosmos? In 2009, Stephen Hawking held a party for time travelers. No one showed up. Could that situation ever change?
So here we are in the future, and we'd really love to go to that party. I heard there's great snacks. How do we get back there?
We know extreme speeds can send us into the future, but the universe has another force that messes with time. Gravity.
Remember that there is only something called space-time, not separate space and time. And what gravity really is a bending of space-time itself.
Think of space-time like a rubber sheet. Massive objects like planets and stars stretch it, bending space and the passage of time.
As you get closer to something with a lot of gravity, time and space are stretched, and that really does mean that time goes more slowly.
It even happens on Earth. Here, time runs more slowly close to the ground.
So what this means is if you live high up in an apartment building, your clock is ticking by slightly more quickly than people living at the bottom of the apartment building. You feel the Earth's gravity slightly differently than they do.
If you live in the top floor of a luxury high-rise in a penthouse, you're actually aging more quickly than someone who lives in the basement.
These time differences are just tiny fractions of a second. But there's a place in the universe where powerful gravitational forces slow time dramatically. A black hole.
A black hole is a region of space where the space is so curved that not even light can escape
A black hole in many ways is a natural time machine. The closer you get to a black hole, the more into that gravity, the slower time goes.
At the center of the Milky Way sits Sagittarius A star, a supermassive black hole with a mass of 4 million suns. To use this natural time machine, we would have to send a spacecraft. The craft would have to travel vast distances through deep space to reach its target, a journey fraught with peril.
The center of the Milky Way galaxy is one of the strangest, most exotic, and violent places in our galaxy.
That gigantic black hole means the environment is filled with things like lots of turbulence, strong magnetic fields, really intense radiation.
And surrounding the black hole, a searing hot disk of gas.
In the vicinity of a black hole, the gravitational field is really strong. But it's not black, and that's because just outside of it, stuff is trying to get in. What it tends to do is circle around in a disk of material that we call an accretion disk that is incredibly dense and hot, emitting high energy particles. There are winds blowing off of it. It's a very violent place, and this is where all the action is.
This is gas that's swirling in closer and closer to the black hole, heating up to millions of degrees, going close to the speed of light.
It's really difficult on Earth to get material moving that fast. And so the fact that there's so much material in this accretion disk traveling at 30% of the speed of light is really mind-blowing.
The backyard of our monster black hole in the middle of our Milky Way isn't for the faint of heart, for sure.
If the craft survives the journey, the crew will see the massive Sagittarius A star up close for the first time and start to feel its effects.
Once that spacecraft gets near the black hole, strange things will begin to occur.
The mission control would see the astronauts say, "Hello." And the astronauts would hear them answer, "Oh my God, I'm worried about you, is everything okay?" Apparently speaking too fast. And then the astronauts would respond, "Oh, I'm fine."
They would seem to be moving in slow motion.
The crew steers the craft into orbit around the supermassive black hole. Mission control might see the craft orbit every 16 hours. But for the crew, the orbit is far shorter. The immense gravity of Sagittarius A star slows the craft's time relative to mission control.
If you enter a strong gravitational field, like near a black hole, and then you come back, you will have experienced less time than someone who just stayed behind here on Earth. But it never feels strange to you. You always look at your wristwatch and the clock is ticking at exactly the same rate as you would expect. You don't even notice that you're in a gravitational field until you come back and compare your clocks to the people who left behind.
In this way, traveling close to a black hole and then coming back allows you to accelerate your passage through time compared to people who stayed behind. So you're jumping in time. You really are time traveling in that way.
If the gravity outside a black hole accelerates a spacecraft through time, what does the inside do? To find out, the crew sends a manned probe towards the black hole's event horizon.
If you could maintain communication with them, one of the things you would observe is that everything would get reddened, that the light is actually losing energy as it comes out of that gravity of the black hole.
It'll get dimmer and dimmer, and eventually, as it falls right onto that event horizon, it just fades out and freezes.
At the event horizon, the probe appears to freeze in time and fade away. But on board the probe, time doesn't change a bit. The crew plunges into the black hole. Inside, immense gravitational forces might stretch the probe like spaghetti. If the craft survives, the crew pushes on towards the central singularity, a place where the laws of physics fail.
The singularity is a true discontinuity, a causal break in the fabric of space-time itself. And that's a fancy way of saying that we have no idea what happens beneath it.
If a singularity is a break in space-time, could it let us jump through time?
What happens on the inside of a supermassive black hole is all very much in the realm of very advanced theoretical physics. In fact, the singularity at the center of a supermassive black hole, it may be possible to even go through it. There's many interpretations of what it could potentially mean. Parallel universes or time travel.
It could be that space and time gets far more chaotic. Different points in space and time connect to each other in every direction. So at the very heart of a black hole, you indeed may be able to access any point in space or time in the universe.
We can't know for sure if a singularity is a portal through time. What we do know is crossing a black hole's event horizon is a one-way trip.
That's the thing about black holes. You ain't coming out.
To return to the present after visiting Professor Hawkins' party, we'll need a different time machine. One that lets us come back. They may exist, but they may also crush anything that enters.